Here is an interesting graph including e as a base with a variable in the exponent. This is an example of the velocity of a skydiver as they step out of the plane. The graph is going to be very sparsely given. There are just going to be a shape and a terminal velocity indicated. The terminal velocity is going to be how fast the skydiver is going to reach. As the skydiver is falling downwards, the air pressure starts pushing upwards until eventually the force due to gravity is roughly equal to the force of the wind pushing upwards, and the skydiver is in equilibrium. First, note that if t is 0, the moment that the skydiver steps out of the window, then my exponent is 0, e to the 0 is 1, 1 minus 1 is 0, 80 times 0 is 0. So I'm going to start at the origin with 0 velocity. As t increases, as t gets to be a larger and larger positive number, we are going to have -2 times t. That's going to be a large in magnitude negative number. E to a negative number is the same as 1 over e to that number. So this would be 1 over e to a large number. That will end up being a very small number. As we make the denominator larger, we make the number smaller. 1 minus a very small number is going to head towards 1. And 80 times 1 is going to be our terminal velocity. So I'll write y equals 80. The shape of this graph, the shape of this family of graphs, is going to be upward and then leveling off. That's all I need you to do in graphing the velocity of the skydiver as they're headed downwards. The way that this works, there's the force due to gravity, and that's going to be constant throughout. The force due to gravity is going to force the speed to get higher and higher. Counteracting that is the force of the air pressure. Now, initially, when you're not moving all that fast, the air pressure, the pressure pushing up against you, is very slight. But as you move faster and faster against the wind, imagine what happens as you put your hand out of the window of a moving car. The pressure is going to be increasing and increasing until eventually the force due to gravity, impelling you to go faster, is going to be matched by the air pressure pushing you upwards.